All right, hello everyone. Here is the long-awaited video for solving systems of equations by elimination. So what I have done is I have combined every lesson that we have done so far on elimination into one video so that you can go back and check this one video instead of having to check like 4 or 5 different pages of notes. Everything will be in one location. So the standard is 8.EE.8b, solve systems of equations in two variables algebraically. And our essential statement is I can solve systems by elimination. We are going to start with, I guess, the simplest examples in the beginning. We're going to work our way up. So what is the elimination method? It's the method used to solve systems of equations in which one variable is eliminated by adding two equations in the system. So we did graphing, where we solved systems by graphing, where you had to graph. We did substitution, where you had to solve systems by substitution, where you had to substitute. Now we're doing systems by elimination, where guess what? You have to eliminate. Now, let's go ahead and start with our first example. Here's our first system. 2x plus 5y is equal to negative 24, and 3x minus 5y is equal to 14. So what is the whole point here? Well, what we need to do is we need to find a variable, either the x or the y, where we can eliminate or cancel out in order to solve the rest of the problem. So over here on the left-hand side, I wrote when the number in front of the variable is the same but opposite, they cancel. So looking at our first example, I know that we have a 5y and we have a negative 5y. If we were to add or combine those two together by adding two equations, they would equal 0, so they would get eliminated. So what you do is you just eliminate them or cancel them out. And the next thing you do, per our definition, we add down. So we have 2x plus 3x, which is 5x. This equals 0, so we don't write anything there. And we have negative 24 plus 14, which equals negative 10. And now this is just a one-step equation that we solve, and you do that by dividing by the number in front of x, which is 5. But whatever we do to one side, we must do the same thing to the other. 5 divided by 5 is 1, so that goes away. So x is equal to negative 10 divided by 5, which is negative 2. But again, we're not done yet because we only solved for one of the variables, but we have two variables to solve for. So how do we get the second variable? Well, to get the second variable, you pick one of your original equations and you rewrite it. So I'm going to go ahead and pick the second one because it looks a little bit easier for me. 3x minus 5y is equal to 14. And again, you can pick either equation. I just like to pick the one that looks easier. And what do I mean by that? Less negatives, smaller numbers, things like that. And I solved for x, which x was equal to negative 2. So I'm going to plug that in right there. So when I rewrite this, I have 3 times negative 2 minus 5y is equal to 14. And then this just becomes an equation. So 3 times negative 2 is negative 6 minus 5y is equal to 14. And now this is a two-step equation where you find the side with the variable, find the number not attached to the variable, and perform the opposite operation. But whatever you do to one side, you must do the same thing to the other. So negative 6 plus 6 is 0. That goes away. And so I have negative 5y is equal to 20. And my last step is to divide by the number in front of the variable on both sides. So I get y is equal to negative 4. And now I have both of my variables, and I still have to write my answer as an ordered pair, x, comma, y. And that is how you solve the system by elimination. It does look like it's a little bit longer, but if you like algebra, then this is the method for you. So what we're going to be doing next is we're just going to be doing a bunch of examples so that you can get more comfortable with this method. So looking at our second example, 10x minus 3y is equal to 9, and negative 10x minus 7y is equal to 21. So I notice that I have a number in front of the variable that's the same but opposite, and that's 10 and negative 10. So what I can do is I can go ahead and cancel that out. Once I find a variable that I can cancel, I can go ahead and add down. Okay, once I add down, I have negative 3y plus negative 7y, which is negative 10y, and I have 9 plus 21, which is 30, and then my last step would be to divide by negative 10 on both sides, so I get y is equal to 30 divided by negative 10, which is negative 3. Now again, once I solve for my first variable, I go ahead and pick one of my original equations, and in this case, I'm going to go ahead and pick my top one. Just looks a little bit easier for me. I'll rewrite it, and because I solved for y this time, I'm going to plug that negative 3 into the y, so I have 10x minus 3 times negative 3 is equal to 9. Negative 3 times negative 3 is positive 9. Is equal to 9. I write down everything I didn't use. All right, and then I just solve it. So 9 minus 9 is 0. 9 minus 9 is also 0. 0, remember, 0 is just a number. You can still use it as a number, okay? It's not like you need to freak out and not know what to do. That's okay. 0 is just a number. And then I bring down the 10x is equal to 0, and my last step would be divide by the number in front of x. So 0 divided by anything is really just 0. It's like 0 multiplied by anything is really 0. So x is equal to 0. And once I have both of my variables, I need to write my answer as an ordered pair, x, comma, y. Notice how I put the 0 first because that is what x equaled. All right, moving on. So here we have our next lesson, which is special cases. This is actually going to go by really, really, really fast. For those of you taking notes, the standard is going to be the same for all of these pages of notes. So write the same standard, and our essential statements do change, so that's why I have those written down. So what are special cases? Let's just do the problem and then you'll see. Okay, so looking at this problem, I notice in my first example that, let me make sure I wrote down the example correctly. Oops, and of course, let me change this up because I didn't write it correctly and now it is correct. So that's important. Remember, negatives are super important. If you miss a negative, the whole problem is wrong. But now I have it correct. So looking at this problem, I have x minus 7y is equal to negative 14, and I have negative x plus 7y is equal to 19. So I'm looking, I'm like, oh my goodness, okay, well, the numbers in front of the x, I have a 1 and I have a negative 1. So remember, I need the same number but opposite sign in order to cancel. So I'm like, okay, well, the x's can cancel because that's a positive 1 and a negative 1. But then I'm looking, I'm like, wait, the y has a negative 7 and a positive 7. So the y's can also cancel. So that's weird. When you have nothing left on one side, what number is really there? The number that's really there is 0. Okay, but then we still have to add down. So when we add down, I have negative 14 plus 19, which is 5. And so I don't even have to do a bunch of work. I get this. And what does this even mean? 0 is equal to 5. This is a statement. Is this a true or a false statement? Well, 0 can never equal 5. This is a false statement. And when we solve a system and we get a false statement, remember back to our different methods like substitution, when we solve a system and at the end we get a false statement, that means we have no solutions. Okay. Now, on the opposite side, we have another example, negative 8x plus 6y is equal to negative 2, and 8x minus 6y is equal to 2. Looking at this problem, however, I notice that, yeah, I can cancel out the x because I have a negative 8 and a positive 8. I can also cancel out the y because I have a positive 6 and a negative 6. But then I notice that I also have a negative 2 and a positive 2 that can cancel. So on the left-hand side, I'm left with 0, but on the right-hand side, I'm also left with 0. I have no variables, but I have a statement that reads 0 is equal to 0. Now, does 0 equal 0? Yes, this is a true statement. And if we solve a system and at the end we get a true statement, that means we have infinitely many solutions. So we have infinitely many solutions. So this is what happens. You'll either get one solution where you have x equals and y equals. You'll get no solution where you get a false statement once you cancel, or you get infinitely many solutions where you have a true statement if everything cancels out. And at the end, you get something like 0 is equal to 0. All right, moving on. So again, our standard is the same. Our essential statement does change. I can solve systems by elimination by changing one equation. So this is different now because what happens here is you have a system, but let's go ahead and look at our first example. 5x minus 4y is equal to 20, and 5x plus 8y is equal to 20. Now I'm looking and I notice that in front of the x, I do have the same number, but I have the exact same number. I don't have the same number but opposite sign, and I need the same number but opposite sign in order to cancel. So for this example, we're going to multiply one equation by -1 before we can eliminate a variable. And it doesn't matter which equation you're going to multiply by. I just want to change one of these x's so that one of the 5's becomes a -5. And the way I do that is by multiplying that 5 by -1. However, the problem now is, well, this isn't really a problem, but remember, you can't just multiply the 5 by -1. You have to multiply the entire equation by -1 in order to keep the equation balanced. So what you're going to do is you're going to multiply the entire equation by -1,